Hi all, welcome back to Python for Data Science tutorial on Tude Fulcrum. In this session, we'll be discussing about Python decorators. In Python, decorators are those which adds some extra functionality to an existing function without modifying the structure of the same. So before getting to know what decorators are actually, let's quickly brush up what a function is. So, as you know, let's define a function using the keyword def. Let my function name be fun and let it simply print a statement hello all. So I have defined my function. So to invoke the same, we need to call it by the name. So I have called my function, or I have put my function to action. So I got my output displayed as hello all. This is basically a function. You could define it as a set of instructions that is performing a specific task. So in Python, we also have a concept of function within a function. That is, you could define one function inside another function. Let's see about the same. So let me define a function. Let me call it as outer function, okay, outer fun. And inside this, let it display a statement inside outer function. I'm going to define another function within this outer function. So how do I do that? It's basically a function that we are going to define. So we need to use the keyword def. So this is defined inside your function, outer function. So be careful with the indentation. I'm going to define another function. Let me call it as inner function. Now I'm implementing it in such a way that let it simply print a statement inside inner function. Alright, we have created function within a function. So we have an outer function inside which we are going to define another function. Now how do we invoke this? To invoke this, we call the outer function. So how do you invoke the outer function? By using its name. My function do not take any arguments as of now. So simply I'll call outer fun. This is a call to the outer function, right? Now, how do we access the inner function, or how do we call the inner function? Do you think you could invoke the same like the outer function? That is, if we try to do something like this, we end up with an error. It says that the inner function is not defined. That means I could say like this: the inner function is protected within the outer function, or the visibility or accessibility of inner function is not available to outside. It is available only within the outer function. So how do we invoke the inner function? So for the same, I will have to call this inner function from within the outer function. That is, I have to call like this. So now if you invoke the outer function, you could say both the outer function as well as the inner function is getting invoked. So how did this happen? You made a call to the outer function. So this function gets invoked. It starts executing its statements. So first is a print statement which displays inside outer function. You have defined another function here. So this definition takes place. Then the next statement here is a call to this inner function which we have already defined. So now it binds with this function definition here, wherein we are instructing to print a statement inside inner function. And that's how we got the output here as inside outer function and inside inner function. This is function within a function. Now let's modify our functions with arguments. That is, same function let's use, but here let me pass an argument. Okay, so I'll print this here inside outer function. let's try to access the value of a. So inside outer function, I'll say a equal to a. So you're pretty familiar with this, that you are 100% sure, I know, that this a value will be available here or accessible here because it's the argument, the formal argument that we receive here. So definitely it should be available within the function definition. Now I'll add an inner function here. Now let this not take any argument. What we're trying to check here is, will our formal parameter a will be available to the inner function as well. Let's check it out. So let's call the inner function here as well. Alright. Now let's invoke the function, outer function. Okay, we missed to pass an argument. So if I pass 12, yes. So can you see this? The formal parameter a is available to the outer function as well as it is available to your inner function. The argument that we pass here is available within the inner function as well. That's what we have proved now. Also, your inner function could take its own arguments. That is, if I have modified like this, I'll pass a value here as well. Let me call it as b. So if I say, let me modify this print function like this. So when you invoke the same, you will have to pass a value here. So if this was the case, that is, our inner function also takes an argument. Yeah, can you see this? I called the outer function by passing 12. 12 is received to a. So inside outer function, the a value here, that is this print statement, get our output as a equal to 12. Inside outer function, a equal to 12. Then we defined the function. So here our inner function also takes an argument. So when you invoke the same, you'll have to pass an argument. So this 3 is received by b here. So inside the inner function, a value is 12. We have already verified that. Now inside inner function, the b value will be the argument that we have passed when we called the inner function. And hence we got the output like this. Inside outer function a equal to 12. Inside inner function also a equal to 12. And inside inner function, the b value is 3. Now let's see another concept with function. For this, let me define a simple function, fun, and let it simply print a statement as we have seen before, hello. This is a normal function. What we are going to do here is, we will assign this function to a variable, and through that variable, we will try to call the function. That is, I'll assign this function name fun to a variable. Let me say s. I'll say s is equal to fun. So normally how do you call the function? By the function name followed by the parenthesis. Now since you have assigned this function name to this variable s, now through this variable s followed by parenthesis also, you'll be able to call the function. In Python, everything is object. Function is also an object. So here the function name fun and the variable s is referring to the same object, I could say. And it's because of this we are able to call this function through this variable s. So what we have done here is, we assigned the function to a variable, and through that variable we have invoked our function. So what is the need for this? Reusability, you could say. Also, if you have deleted your original function, I deleted this function fun. Now if I try to call the function fun, it's end up with an error. But now still you have assigned this function to the variable s. Though you have deleted your original function, you will still be able to call the same through the variable s. So you could say like it's not a copy but a backup kind of thing that you have done with your function. Now before getting to decorator concept, you need to know something known as closure properties in Python. So to work with closure, we need to have function within a function. So let's create a function within a function. Let's define our outer function. Let it take an argument x. I'll define an inner function. Let it not take any argument. And let me simply print the value of x here. So you know x will be available to the inner function as well. Let me add a return statement like this. Return inner fun. So in the previous example, instead of this return statement, we were calling the inner function directly. Right? This we have seen. Now instead of this, what I am doing is I have written a return statement. What am I returning? The function name I have returned. Let's see how this entire process is going to work. I'll use a variable here to call the function because it's returning something. So you need to have somebody here to receive the return value. Let me call it as variable a. I'm saying a is equal to outer fun. I'll pass a value 2 here. Right? Along with this, I'll do something like this. So variable a is having the return value of this function. Now what is this function returning? It is returning the name of your inner function. So to invoke the entire process, I could do the same through this variable. This is previously what we have seen. I could say here that I'm returning the inner function name to a variable, and then later on through that variable I'm trying to call the function. I'm getting the output 2 here. So how did I get? So this is a call to the function. It binds with the function definition here. That is, x will receive the value of 2. It defined the inner function, and then you have a return statement. So what is it returning? This outer function is returning inner fun. Outer function returns the inner function name. So the return value is received by a. So a will be equivalent to what? Inner fun. So if a function name is assigned to a variable, we have already seen that through this variable we will be able to call the function. This is exactly what we have done here. So if you call the function inner function, it is printing the value of x, and the x is holding a value of 2, and that's displayed here. So actually by this statement, a equal to outer fun of 2, my function execution is completed. But still I'm able to call the function again. I'm still able to access the data. This is called as the closure technique. So after my function is completed its execution, still I'm able to work with the function. Still I'm able to access the data. This is called as the closure technique in Python. So the criteria to bring about the closure technique in Python is we must have nested function, right? We have used nested function here. The nested function must refer to a value that is defined in the enclosing function, and the enclosing function must return the nested function. We have returned the nested function. This is closure technique in Python. In Python, it's possible to pass functions as arguments to another function. You could pass one function as an argument to another function. That is something like this. Let's define a function add. Let it take an argument, let's say a, and it is returning a plus 1. Let's define another function, say sub. Let it also return an argument a. Let it receive an argument a, and let it return a minus 1. Right? I'll define one more function. Let me call as calculate. Let this function take two arguments. The first one is fun and the second one is say x. R is equal to, I'm saying fun. That is the first argument, fun of x. Let me return R. This is another function. Now let's see how I'm invoking the functions. Are you able to see an output 7 here? So how did I get this? I'm calling this calculate function here. Look at the arguments of calculate function. What is add? Add is another function which we have already defined, right? Add function, how did we define? We defined add at taking an argument, it is returning a plus 1. So this entire function is passed as an argument to our calculate function. So the function name add is passed here. It is received by fun. So recollect the property. We are assigning function name to another variable fun here. So fun of x is equivalent to, that is fun of x is equivalent to calling the function by passing x as an argument. So if you pass x, now what is x here? X is 6. X is 6 here. So this is equivalent to calling the function add by passing 6. So what is this add function doing? It is returning a plus 1. Now what is a? A will be 6. So this is equivalent to returning 6 plus 1, that is 7. So R will hold a value of 7. So if you return R, it is equivalent to returning 7. The 7 is received by RES. We are printing the same and hence we got the output as 7 displayed. So what did we do here? We passed one function, that is the add function here, as an argument to another function. Now let's get back to the decorator concept. So Python decorators makes use of closure. As I said, a decorator takes in a function, adds some functionality and returns it. So adds functionality to an existing code. This is sometimes referred to as meta programming because a part of the program tries to modify another part of the program at compile time. So everything in Python, as you know, are objects. The names that we define are simply identifiers bound to these objects. So functions are no exceptions, they are objects too. Various different names can be bound to the same function objects. So let's start implementing the decorators in Python. So it is going to work with the closure property. That means we will need to have function within a function. I'm defining a function here. Let me call this as fun and let it work with an argument. Let me say adds. Now I will have an inner function here. Let me call it by name sum of squares. Let it take two arguments. Let's say n1 and n2. Now let it be like this. C is equal to, I will say adds n1 square. The second argument, let it be n2 square. And let this function return the C value. So let the outer function return the inner function. Now let's define one more function, add. Let it take two arguments x and y, and let's implement this in such a way that it is returning the sum of x and y. So what I'm trying to do here is this add function, I'm going to decorate it in such a way that it's modified like it's computing the sum of squares of two numbers. I'm going to decorate this add function. So how do I decorate this? In Python, you could decorate the same using @symbol. How am I decorating? I'm not going to change the structure of this add function. I'll decorate it by simply saying fun. So this function fun is going to decorate our add function. So how is this going to work? Let me just write down the invocation part, then I'll explain the entire code. So I'll say like c is equal to and of 2, 3. I'll invoke this add function here. This is the structure of the function. This is our add function. We are not going to change the structure of that function. So invoking the add function also we are not going to change. But when we call the add function, you see what the output are we going to get? Are we going to get 2 plus 3, that is 5? Or are we going to get 2 square plus 3 square? It's 13 the output what we got here. So the output is exactly 2 square plus 3 square. How did we get that? When we say this @fun, actually what happens here is, it is equivalent to saying we use a variable, let's say any variable, s is equal to, we are calling the function fun by passing add function as an argument. And then invoking the function through the variable s. So we have seen this process earlier also. This is decorator concept in Python. So we didn't modify the structure of the add function here. Our decorator function added an extra functionality. It was modified like instead of computing the sum of two numbers, it was modified in such a way that it computes the sum of squares of two numbers. This is Python decorator concept. Thank you so much for watching. Please do like, share, comment and subscribe. And please don't forget to tap the bell icon. You'll get notified whenever we upload a new videos. Thank you.